In this video, we will be discussing about swap nodes in pairs. Given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list nodes, that is, only nodes themselves may be changed. So what they are saying is that in the input, we are given a head of a linked list. What we need to do is that we need to swap. We need to swap every two adjacent nodes. Adjacent nodes meaning these two are the adjacent nodes, these two are the adjacent nodes, right? If there is one more over here which is single, so this has to be remain unchanged, right? Because there is no adjacent node for that, right? Then whatever is the new head of our linked list after swapping the adjacent nodes, we need to return that new head as our answer, right? Another thing is that we cannot just swap these values. We need to swap the nodes itself, right? So now see here, this is node 1, this is node 2. These two nodes have to be swapped, meaning node 2 will come here and node 1 will go here. Then what will happen is that node 2 will be here, right? And node 1 will come here, right? So our linked list will then look like this. Now we need to swap these two nodes, right? So what will happen is this node 4 will come here, so 4 will come here and 3 will go here, right? So this is how our new linked list will look like, and this node 2 is the new head of our linked list. So a pointer to this node 2 has to be returned in our answer, right? So now how are we going to solve this problem? So firstly, we are supposed to swap the adjacent nodes, right? And then we also need to retain the head of the linked list, because as we will move forward, we will lose our head, right? For the purpose of returning the head, we will have to maintain some pointer that will point to the head or the new head of our linked list, right? So in these type of situations, what we do is that we create a dummy node, right? We create a dummy node. Now this dummy node, what it does is in its next pointer, it stores the head of our linked list, right? So that when we do all the modifications in our linked list, at the end, in the next pointer of dummy node, we have the head of our linked list, right? So this dummy node approach we follow whenever our head gets modified, and we need to keep the track of our head in our linked list, right? So firstly, we will create this dummy node, right? Now we need to swap these two nodes, right? So that how are we going to do? So see, since I want to swap these, I would be having some pointer which should be pointing to these nodes, right? So let us suppose that I have a pointer named current or cur. So this will point to my current node, right? Now this current node initially is pointing to head, right? So initially what we did was that we created a list node named dummy, right? The syntax we'll see while writing the code. And then we created a pointer, another pointer that is current, which will initially point to head. That I'm saying because this is the first node that we will be considering, right? Now, this node has to replace node 2 and node 2 has to replace node 1, right? So what will happen is that this pointing will be broken and 2 will now point to node 1, right? Then this pointing will be broken and node 1 will now point to node 3, right? And since now node 2 is the new head, our dummy should point to node 2, right? So see, for swapping these two nodes, what all nodes were involved? This node's next was involved, right? A reference to this particular node was involved, and these two we are anyways swapping, right? So we used a reference of all these four nodes, right? So this node we are referring with current, right? Now we need the node previous to this node also, right? Because whatever is the node that will come here, the previous node should now point to that particular node, right? So what we will do is that we will make another pointer which will be previous, right? And it will tell us that what was the previous node in the previous set of adjacent nodes, right? So since initially before this there is no node, we will keep it as dummy, right? Previous will point to dummy. You will understand why we are pointing it to dummy. So previous is right now here, right? So now once we are set up with all the initial work, now we will start actual work of swapping the nodes, right? So what we need to do first, we need a reference to the node 2 and node 3, right? So this is going to be our future node, right? This node is just for the purpose that from node 1 in its next, I want to point it to node 3. That's the only reason that I want a reference of this particular node, right? Now, how will you get a reference to this particular node? So you have a pointer current pointing to this particular node. In its next is this particular node stored, right? So I am calling this node as future node. So what we will do is that we will take a list node named future, right? In that we will store currents, nexts, right? So what will happen is that future will be pointing to node 3, right? Now that I have reference of these three nodes, I want reference of this node. Let's call it the second node. So this is the current node, this is the second node, right? So let's take a pointer second. What it will store? Currents next, right? So currents next, right? So second is pointing to node 2. Now here the main logic comes that how are you going to swap these pointings, right? So see, what we wanted was we wanted to remove this pointing and we wanted to point node 2 to node 1, right? So basically in seconds next, we want node 1, which is nothing but the current node, right? So what we will do is that in seconds next, we will put the current node, right? So this particular linkage will be removed and 2 will now point to node 1, right? Then what we want is we want that this particular node 1 should point to node 3, right? So basically currents next should be pointing to future, right? So here what we will do is that in currents next we will give future, right? So this linkage will be removed and node 1 will now point to node 3, right? Now, since this is coming here, our previous should point to node 2, right? Because we do not want our linked list to be broken in between. This node should not be hanging without any reference, right? So in this previous, we will store node 2, which is nothing but second, right? So in previous next, what we will store? Second, right? So what will happen is that this dummy would now be pointing to node 2. So this is how our linked list will look like after these operations, right? So let me draw this linked list again so that it is more understandable. So first we have a dummy node, right? This is the dummy node. Then this dummy node is pointing to node 2. So we will create a node 2 over here, right? Then 2 is pointing to node 1. So we will create node 1 here, right? Then node 1 is pointing to node 3. So we will create a node 3 over here. And then this 3 is pointing to 4. So we will create a node 4 over here, right? And the pointers are previous is pointing to dummy, current is pointing to node 1, second is pointing to node 2, and future is pointing to node 3. So this is how our linked list looks like. And we have successfully swapped these two nodes, right? Now we need to swap the next set of adjacent nodes, right? So since previously we were swapping these two, right? So current was pointing to the first node in this set. So now for these, current should now point to node 3, right? Where is the reference of node 3 stored? In the pointer future, right? So current should now point to future. And what should be the previous? So for this set, dummy was taken as the previous. So for node 3, what should be the previous? Node 1. Because whichever node will come here after swapping, node 1 should point to that particular node, right? So we should have a reference of this node 1 and a reference of this node 3. So this should be the previous and this should be the current. So what we will do is previous will now point to current and current will now point to future. We cannot change current first because then this previous won't point to the correct node. That is why first we are changing previous and then we are changing current, right? So what will happen is, what have we written? Previous would point to cur, right? So previous will be removed from here and now it will point to node 1 and cur will point to the future node. So cur will be removed from here and now it will point to node 3, right? So this is how our pointers will look like. So this entire thing we will do for one set of adjacent nodes, right? So I'll just write down here that this will be happening inside a loop. The conditions for this loop we will see later, right? So now this is how our linked list looks like. So now we will come in another iteration. Future will point to what? Current's next, right? So current is pointing to node 3, its next is 4, and 4's next is null, right? So future will now be pointing to null, right? It will be removed from here. Then in second, we are giving currents next. Current is node 3, its next is node 4, right? So this second will come here now, right? So this is how our pointers look like. Now what we are doing in seconds next, we are giving current. So basically in node 4, it is right now pointing to null, but with this statement, it will now point to the current node, which is node 3. So this node 4 will now point to node 3, right? This will point to node 3, right? Then next statement is in currents next, we will give future. So currents next is this. This will be removed and it will now point to future, which is null, right? So this will be removed and this node will be pointing to null now, or this node's next will be pointing to null now, right? Then what is the next statement? In previous next, we will give second. So previous is node 1. Its next is right now pointing to node 3. So this linkage will be removed and now it will point to node second, which is node 4, right? So node 1 will now point to node 4, right? So now if I draw this so that you are able to understand. So this is the dummy node, right? Then we have node 2, then we have node 1, then this one is pointing to node 4, right? So we will write node 4 over here. Then this node 4 is pointing to node 3. So we will create node 3 here, right? And this node 3 is pointing to null. So this is how our linked list is looking like at the moment, right? Previous is pointing to node 1, current is pointing to node 3, second is pointing to node 4, and future is pointing to null, right? Then these two will be executed. So current will be changed to previous. So basically, previous will now point to node 3, right? And current will now point to future. Future is null. So now current will also point to null, right? So now you will see that we are done with swapping these two adjacent nodes also, right? And now our current is pointing to null. Then that means we are not left with any more nodes to swap them, right? So in the while loop, our condition will be that while current is there, while current is not null, we will do all these things, right? Now one more situation was that in this particular case, we were given even number of nodes. What if there was one more node here, node 5? In that case, for this node, there is no adjacent node, so we need to keep it as is, right? So in that case, what will happen is that after these iterations, your current would be pointing to node 5. This 3 would be pointing to node 5 and your current would be present here, right? Then in that case, it will go inside the loop because our current is not null, right? So we will have to put a check for this as well, because for node 5 we do not want any swapping to be performed. Now what is that check that we can give? So when node 5 would be present here, it won't be having a node next to it, right? Its next is pointing to null, right? So what we can do is we can keep one more condition here, that while current and currents next, right? So if current node is also there and current's next node is also there, only then we will perform this swapping, right? So with this, we will be able to swap all of the adjacent nodes, right? Now at the end, we are supposed to return the head. This dummy is pointing to our head, right? So at the end, we can simply return dummy next, right? So with this, we will be able to solve our problem, right? And now here, we are just keeping pointers to our nodes and we are moving in the forward direction. There is only one loop going on here, right? And it is pointing to all the nodes in our linked list. So the time complexity of this approach will be order of n, where n denotes the number of nodes in our linked list, because there is only one loop that is running for the nodes in our linked list, right? So let's code it out now. So let's remove all this. First of all, we will create a dummy pointer, right? It will be new list node. We don't want to give it any value, and initially we can keep its next also to null. Then another pointer that we need is a previous pointer that should be pointing to dummy initially. Then we need another pointer current, which should initially be pointing to the head, right? Then we need to run a while loop that while current is there and current's next is also there, right? What you will do? First, you will create a reference for the future node and the second node. So list node future will be equals to currents next, right? And then we will create a pointer to the second node, which will be currents next, right? Then we will swap the next pointers of the nodes. So seconds next will point to current node, currents next will point to future node, and previous next will point to the second node, right? And then we will move our pointers forward. So previous will now point to current will now point to future, right? And at the end, we can simply return dummies next, right? And now it might be possible that in some edge case, there is only one node in the linked list or there is no node at all, right? So in that case, we need not to do any swapping, right? So for that, we can put a condition in the starting itself that if head is null, right? That means there are no nodes in the list, or the heads next is null, meaning there is only one node in the linked list, right? So in that case, we can simply return the head. We need not to do any swapping of the nodes. So this is our edge case, right? So let's run the code. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.